Hi everybody, this is Mrs. Harding again. Today we're going to take a look at activity 9.2a. So go ahead and get that into your OneNote notebook. This is what we're going to cover today. We're going to actually carry out a significance test. So in section 9.1, you went through all the big ideas of errors and conclusions and writing hypotheses. What we're going to start doing now is to actually write out the test. Let's start with the basketball question that we've been talking about throughout 9.1. It says, remember that our basketball player claims that he can make 80% of his free throws, and we feel it's less. Suppose we have him shoot 50 free throws and he makes 32. Is that sufficient evidence to reject his claim? So remember the steps here that we're going to go through with a confidence interval, or that we did go through with a confidence interval. We're going to do the same thing with the test: the state, plan, do, and conclude. So what I'd like you to do right now is pause the video and write down what you believe the null and alternate hypotheses are. So then, as you remember from the previous activities, the null hypothesis is that the player shoots 80% of their free throws, so P is 0.8. The alternate is that P is less than 0.8. The player makes less than 80% of his shots. The planning portion of this test is to go through the conditions. Now, we're talking about a population proportion. So we need to check for randomness, we need to check for independence, and we need to check for normality of the sampling distribution. So you can take a look at what I have on the screen here. The first condition is a little bit interesting. You can see that. It says we will assume the 50 free throws are an SRS of the player's shots, but clearly this is not true. It was not randomly selected. He just showed up in the gym one day and shot 50 free throws. So this one isn't really met, but we're going to proceed as if the conditions have all been met. 50 is probably less than 10% of all the players the free throws the player has shot. And then in the end, the expected number of successes and failures are both at least 10. So this is just addressing the conditions. The randomness is really actually not met, but that's the planning step. The next step is to actually carry out the test. So what does carrying out the test mean? Well, that means that we need to determine where our sample falls on the sampling distribution. So if you take a look at the work on the screen here, we have our sampling distribution. The mean of the sampling distribution is the proportion from the null hypothesis. You'll see that symbol being a p subscript 0 is 0.8. Where did our sample fall? Our sample fell over here at 0.64. That was the proportion of success in this sample. The p-value that we're looking for to draw a conclusion here is the probability of getting a sample as extreme or more extreme than the sample that we're looking at. So that means we're looking for this area on the normal sampling distribution. This area right here is the p-value. Writing that out in symbols, remember that this is a conditional probability. This is the probability that p hat is less than or equal to 0.64, given that p sub 0 is 0.8. So we're going to go through and find the z-score for this. We get negative 2.83. The probability of z being less than or equal to negative 2.83 is 0.0023. This is your p-value right here, which you're going to draw your conclusion from. All right, then in part D it says to make your conclusion, interpret the p-value in context. All right, so what this is saying is if the null hypothesis is true, so if the player really does make 80% of his free throws, there is only a 0.0023 chance of the player shooting 64% or less, or of getting a sample as extreme as ours. Therefore, we're going to reject the null hypothesis and conclude that the player shoots less than 80%. If we're basing this off of our typical alpha level of 5%, we're clearly below 5%. This is statistically significant. It's very, very, very small. And we're going to reject the null hypothesis. Our conclusion here is that we have evidence to support the fact that the player actually shoots less than 80%. Then in part E, it asks, what type of error do you risk making? Well, because we rejected the null hypothesis, we felt we had evidence to reject it, then we are risking a type 1 error. Type 1 error happens when you reject the null hypothesis even though it's true. So we risk incorrectly concluding that the player shoots less than 80% when he actually does shoot 80%. Okay, then flip to the next page. Let's get a little more specific about what we just did. What we just conducted was a one sample z-test for proportion. The names of these tests are going to be important. And in here, we have a general format for what's called the test statistic. The z-score that you calculated in the last question is called the test statistic. We took the statistic minus the parameter divided by the standard deviation of the statistic. Remember, statistic is sample, parameter is population. So we should know where to find that on the formula sheet. You're going to backtrack a little bit. If you take a look at your formula sheet, it's here in the beginning of part 3, standardized test statistic here. Okay, so let's take a look at the actual test and the details of what we just went through. Says that you're choosing an SRS of size n from a large population of unknown proportion of successes. To test the hypothesis, we need to compute the statistic. Apologize, I'm tripping over the word statistic right now. And so then to be specific here for this test statistic, here is z equals, this is from our sample, population, standard error. You are either looking at P, the actual proportion is greater than the hypothesized proportion, it's less than, or it's not equal to. Those are the 3 scenarios that you're taking a look at in this test. And you can see on a normal sampling distribution where that's located. These are one-tail hypotheses. This is a two-tailed hypothesis. And as always, this test really only applies if the 3 conditions are met. Let's come back to the other example that we talked about with the blemished potatoes. It says the chip producer from the previous investigation has just received a truckload of potatoes from its main supplier. Recall that if the producer concludes that more than 8% of the potatoes in the shipment have blemishes, the truckload of potatoes will be rejected. A supervisor selects a random sample of 500 potatoes from the truck. An inspector reveals that 47 of the potatoes have blemishes. So this is our statistic, 47 out of 500. I would like you to pause the video and give this a try for yourself. Carry out a significance test at the level of alpha equals 0.10. What should the producer conclude? All right, let's go through all of the steps here together. We're going to state the hypotheses. The null hypothesis is that the potatoes are only have 8% of them are blemished. It says no more than 8% of the potatoes in the truck are blemished. The alternate hypothesis is that more than 8% are blemished. Then we're going to go into the planning stage where we're going to make sure that all of the conditions are met. The sample is stated to be random. Randomness is met. It seems safe to assume the truckload contains at least 5,000 potatoes. So we should have met the independence condition. And then the expected number of successes and failures are both at least 10. So we're going to say that all of the conditions have been met. The next step in here is to go into the actual calculations. So you can see on the screen, I drew the sampling distribution. Sampling distribution is normal. The mean of the sampling distribution is 0.08. Our sample falls up here at 0.094, so we're looking for this p-value, this area that is at least as extreme as 0.094. So what's the probability of getting p hat is greater than or equal to 0.094 given p sub 0 is 0.08? We come up with a test statistic of 1.15. The p-value then is 0.1251, a 12.51% chance of getting a sample as extreme as the one that we're looking at. And remember that we're talking about an alpha level of 0.10. So since the p-value, which was 0.1251, is not less than the alpha level, 0.1, we fail to reject the null hypothesis and conclude that there is not enough evidence to reject the load. We do not have a statistically significant sample, and the inspector would not reject the load. Into the next page, the top part says, interpret the p-value for this test in context. Now, we're not drawing a conclusion about the potatoes themselves. This question is just asking you to explain, what does this p-value mean? So remember, the p-value is the conditional probability. So in here, if no more than 8% of the potatoes have blemishes, so if that null hypothesis are true, then the chance of getting a sample of 500 in which 9.4% or more are blemished is about 0.1251. That's interpreting the P level. What type of error do you risk making with this test? Well, let's look back. We failed to reject. If we fail to reject, we are risking a type 2 error. A type 2 error is failing to reject a null hypothesis that is actually false. So in this scenario, we would be accepting a load of potatoes in which more than 8% are blemished. Don't get confused by that word accepting. We're talking about deciding whether to keep or send back a load of potatoes. So therefore, we would decide the potatoes are fine, they're fine. So we're going to keep them when in fact they're actually not. Now take a look at part D. Sometimes this will come up too. It says, suppose the supervisor had inspected a random sample of 500 potatoes from the shipment and found 33 with blemishes. What's the value of P hat? Well, the value of P hat in this case, 0.066, that is less than 8%. We are speculating, or we're testing to see if more than 8% have blemishes, and the sample I came up with is less than 8%. So there's not really any test to conduct here. We have a sample that is less than 8%. So then if you look at these questions down here, does this sample support the alternative hypothesis? No, it doesn't. It's not more than 8%. So under these conditions, is it necessary to continue with the significance test? It is not. We would fail to reject the null hypothesis just on the basis of the P hat that we came up with for our sample. And then in part E, it asks the question, even though we really don't need to conduct the test of significance, you might end up carrying out the test anyway. Assuming all the conditions have been met, what would be true about the p-value of this test if we carried it out? And you can see on the answer key, really without any work, it says it would be more than 50%. There would be more than 50%. How do you know that so quickly without doing any work? Well, because 0.066 is less than the mean of the sampling distribution. Remember, 0.08 would be here, 0.066 somewhere over here. The p-value, that's more than 50%. So clearly it does not fall into the category of statistically significant. So the last thing that I want to show you here is how to do these significance tests in your calculator. You can do a 1 proportion z-test there. Go to the Stat button, arrow over to Tests, and you will see the screen that is shown in your activity. You're going to go down to number 5, which is a 1 proportion z-test. And in there you can enter the information that you have. And underneath this proportion here, you would select the appropriate direction of your test. So are you conducting a two-sided z-test? Are you conducting a one-sided where you're less than the null hypothesis or greater than the null hypothesis? And then you can hit calculate and compare this with the results that you came up with by hand. The last thing that we're going to do here is take a look at the bottom of this page. There is a problem that I would like you to pause your video and work through this question. All right, let's see how you did. So in the first step, this state, the null and alternate hypothesis. The null hypothesis is that it is exactly what was stated by that organization, that the true proportion is 20%. So the proportion of teens at this high school that have posted inappropriate images of themselves is 0.20. The counselor at the school is worried that the figure at her high school is actually higher than that. So the alternate hypothesis, and I realize that that says H sub 0 there, that should say H sub A, that the true proportion is actually greater than 0.2. All right, then let's go through the conditions for a 1 proportion z-test. Randomness, it was stated to be a random sample. 250 is less than 10% of 2,800. The school has 2,800 students, and 250 is less than 10% of that. The expected number of successes and failures based on the null hypothesis is both at least 10. All right, so then we'll move into the calculations for the p-value. Our sample statistic is 0.252. So this is our normal sampling distribution with a mean of 0.2. Our sample falls up here, 0.252. So this area under the sampling distribution is the p-value that we're looking for. So the probability that p hat would be at least 0.252, given that the true proportion is 0.20, comes down to this. Z is greater than or equal to 2.06. What we have found is a p-value of 0.0197. Let's talk about the conclusion. Because our alpha level is typically 0.05, the p-value that we found for this scenario is less than the alpha level. 0.0197 is quite small. There's a very rare chance of getting a sample like this if the null hypothesis were true. So our conclusion is going to be to reject the null hypothesis. And it says on the screen there's evidence that the proportion of teens at this high school that have posted inappropriate images of themselves is actually more than 20%. All right, that brings us to the end of this activity. If you have any questions, please let Mr. Bowman or I know. Enjoy the rest of your day.